this video, we are going to talk about estimation of one random variable from another random variable. I am going to present the theory and a problem based on it. Welcome to the lecture by Dr. G. Lavanya, Assistant Professor from Department of Mathematics. Let us assume that random variables x and y are going to have known mean, standard deviation and correlation, which are going to be specified by say eta x, eta y respectively, and the standard deviations by sigma x, sigma y respectively, and the correlation is going to be represented by rxy. Now let us consider y tilde to be the approximation. Then y tilde to be the approximation of x, our random variable, and fix it as a linear function of x. When we fix this as a linear function of x, y tilde will take the form ax plus b. We can take this equation as equation number 1. It is desirable to select a and b, so it is always desirable to select a and b so that it gets minimized, y tilde gets minimized. So we select a and b so that y tilde is minimized. With this in mind, we start the derivation. So we already have seen and we are in a position to understand that EMS is nothing but E of y minus y tilde the whole square. In the previous lectures, you would have seen that y tilde was a constant a. Here, that constant is being replaced by the linear term ax plus b. That is the only difference. So, y minus, you will have ax plus b for your y tilde, the whole square. Now, we will look for the necessary conditions for a and b for minimizing this y tilde. So, necessary conditions for a and b to minimize. On the whole, we are interested in minimizing the error, so we can take that directly. So we need to minimize EMS. So how do we go about this? If you have looked into the constant case, we had only y minus a, and so I would have differentiated e with respect to a and equated it to 0. But here I am going to differentiate this with respect to a as well as with respect to b. So let me take this as my equation number 2, and now we differentiate equation number 2 with respect to a and b, and then we equate to 0 and resolve. So the procedure, there is not nothing of a change, only that we are going to have two derivatives over here, and now your d will become dou because you have a as well as b to go about the differentiation. Now let us consider this. I need to have dou by dou a of EMS. This is nothing but when I differentiate this expectation, I will have E of 2 into y minus, I will have ax plus b into this derivative of minus of ax plus b will once again with respect to a yield me a minus x, and then I need to equate this to 0. Differentiating with partially with respect to b, I will have e of, again I will have 2 into y minus of, I will have ax plus b into derivative of b is just 1 with respect to b equal to 0. Consider these two equations and try to resolve. Let me take the first equation on the top. I have started numbering the equation. I have reached 2. So I am going to take this equation as equation number 3, and I am going to take this equation as equation number 4. Now I suppose 3 implies when I expand I will have e into y minus of my ax plus b into minus x. This value equal to 0. Now please try to expand this term. When I expand this term, I will have e of xy with the negative sign, and I will have plus x into ax plus b. Now let us equate this whole thing to 0. Now this will give me, I will have e of minus xy plus e of ax squared plus bx equal to 0. I have just expanded and used linear property of expectation. Now let me see what happens when I consider this particular expansion. I will take this e of minus xy to the other side. So I will have e of my xy, and this value is now equal to a into, I will have e of x squared plus I will have b e of x. So my e of xy, this value equal to a into, I will have e of x squared plus b into, my mean is represented as eta x, so I replace this as eta x. My numbering now continues. It goes from 4 to equation number 5. Now look at this equation 4. Actually, when we go back to the previous slide, will imply y minus ax plus b expectation equal to 0. So this is expectation of y minus ax minus b, or if I take like this, is equal to 0. This will give me my e of y will be equal to a into e of x plus b. But what is e of x? Eta x. And what is e of y? Eta y. So I will have eta y equal to a into eta x plus b. So this gives me b equal to eta y minus a into eta x. Let us now get back to e of xy and try to resolve. E of xy minus eta y minus eta x. So this will give me my e of xy minus my eta y into eta x equal to a into, I will have e of x squared minus a into eta x the whole squared, and this gives me my a value. My a value over here would be e of xy minus, I will have an eta x, I will have an eta y divided by, I will have e of x squared minus my eta x squared. Now consider e of xy minus eta x eta y. This in other words would give me mu xy divided by, in the denominator it is nothing but our variance, which is nothing but square of the standard deviation, and the standard deviation was given the notation sigma x, so variance would be sigma x squared. Once we have got a, resolving b would not be an issue. B is eta y minus a eta x, so b equal to eta y minus a into eta x. So this value is now eta y minus, I will have mu xy by sigma x squared into eta x. So I may number this equation in continuity to be my equation number 6. Now the matrix of second derivatives are always positive definite by property. Let us now make a mention of this, since the matrix of the second derivatives since the matrix of the second derivatives are positive definite, A and B will give minimum square error. This A, what we have computed, and B, which we have computed, will give minimum, this will give minimum square error, which is our first objective. Let us now evaluate our EMS. What is our EMS? We know very well my EMS is nothing but E of y minus y tilde the whole squared. Here my y minus y tilde the whole squared happens to be in this particular case as E of, I will have y minus ax plus b, y minus of ax plus b into y minus ax plus b whole square. I am sorry, I have multiplied twice, whereby the whole square is not needed as I have written the term separately. Now let me consider this and start my expansion. So this would give me E of y with the second term, which is nothing but E of, I will have y minus ax plus b, this term, into y. By linear property, the negativity comes outside, minus expectation of, I will have y minus of, I will have ax plus b into this ax plus b. Now consider expanding the terms. Before we consider expanding the terms, we have already found out that this second term will become 0 from the previous equation, where we resorted to this value, where we have actually got, see here, what did I get? E of y minus ax plus b, that value becoming 0 over here. So now let us come back to this slide, and so here once again if I apply linear property, this would now give me, I will have E of y minus of ax plus b into my E of ax plus b, and this particular term will now be equated to 0. Hence, this entire term on the right hand side, the second term vanishes and tends to become 0. Okay, with this in mind, what happens to our EMS? Now my EMS is slowly getting reduced to, I will have the first term, expectation of, I will have y minus of ax plus b, this whole thing into y. Okay, so we will now replace our b. What do I know about my b? I know that b is nothing but eta y minus a into eta x. So if I consider this y minus eta y plus a eta x, what actually happens for us to our EMS? My EMS is now going to be equal to expectation of y minus, I retain my ax, I have a minus b which will now become minus eta y plus a into eta x, this whole thing into, I have y. Now this second y which I have over here could be rewritten as y minus, I'm going to add an eta y and I'm also going to subtract an eta y. Just writing y as y minus eta y plus eta y for our simplification purpose. Now start expanding this value. See, here you have an y minus eta y, so we will write these two things together, giving my EMS to be E of, rearranging my terms, I will have y minus eta y put together minus a into x minus eta x. I am taking this term and I am taking this term. This whole thing I will have to multiply with this term again, y minus eta y, okay, plus eta y. So I will take this together and I will just hold my plus eta y over here and now try to execute this multiplication. When I start executing this multiplication, I have my EMS to be expectation of, I will have y minus eta y whole squared plus the second term becoming expectation of y minus eta y into eta y. Now I will take this minus a, this term. Minus a is a constant, it comes outside. Minus a expectation of, I will have x minus eta x into, I will have y minus eta y. I will have again minus a expectation of, I have to go for x minus eta x into eta y. So here I will have x minus eta x into eta y. So we are landing up with four terms, two positive and two negative. Okay. This on simplification, I will have EMS equal to, look at the first term here, it is y minus eta y the whole squared, which is nothing but the variance of y. So I will have sigma y whole squared minus a into expectation of, I am simply expanding the second term, I will have a into e of xy, e of, I am going to have xy plus eta x eta y, a into expectation of xy plus I will have eta x eta y minus I will have x into eta y minus y into I will have eta x. Let us close the bracket here. If I combine everything together, so this once again gives me sigma y square minus a into, I can write this as e of xy minus I will have eta x eta y and this is nothing but I will have sigma y squared minus a into, this value is nothing but our mu xy, okay. So this will give me, again I have to multiply by mu xy by sigma x squared, so this will give me mu xy into another mu xy divided by sigma squared to complete the expression, which will lead me to sigma y squared minus, when I multiply this, I will get rid of a, because only by substituting for this a by mu xy by sigma squared I am getting the answer. Let us make a quick review of this. Let us go a little above. We are having y minus ax plus b the whole square. From this we are resolving. When we resolve, see, a eta x is equal to eta y by minus b. Then what is my a over here? In this case, I am having my a to be mu xy by sigma x squared. So this is how we proceed to come down and substitute for our a in this position and replace our a by mu xy by our sigma x squared. So let me now remove this a and replace it like this. So this will give me my sigma y squared is equal to, I will just have mu xy divided by my sigma x squared. This is our final expression. To continue with our numbering, let us check till where we have gone with the numbers, or we may take this simply as Roman number 1. For this is one of our main results. Hence, the minimum mean square value seems to be the original variance of y. Okay, so this is nothing but the original, this is the original variance of y. Okay, next we will go on to see a simple illustration for better understanding. So let us consider two random variables, say capital X and capital Y, which are characterized by their joint probability function, by their joint probability function fxy of x comma y, which is given by my fxy of x comma y is equal to 2 times xy for 0 less than equal to y less than equal to x, 2 times xy for my 0 less than equal to y less than equal to x, and 0 less than equal to x less than equal to 1, which I term it to be as R1 region, and it is 0 in all other places. So this is our joint PDF which is given to us. What is it that we have to find? Find the best linear estimate of y. This is the first thing. Find the best linear estimate of y in terms of x. This is the first thing, where best is in terms of minimum mean squared error sense, where best is in the sense of minimum mean square error sense, and also determine and also determine the corresponding determine the corresponding mean squared error. So we need to do two things with respect to solving of this problem. One is we need to find the best linear estimate of y in terms of x, and then to determine the corresponding mean squared error. Okay, let us see how to go about this. Okay, the first thing what I would like to do is let me rewrite my function so that I will be able to go about the solution easily. The joint PDF is given by fxy of x comma y. This value was given to be 2xy. Here it was 0. The range 0 less than equal to y less than equal to x, and 0 less than equal to x less than equal to 1, which I termed it to be R1, and it was 0 in all other places. If you plot this region, how will this region look like? That should be our first and foremost primary concern. So if I am going to plot this region, just see how this plot is going to occur for us. We are going to have 0 less than equal to x less than equal to y. So let us first draw the line x equal to y. This is going to be a line inclined at 45 degrees to between your x-axis and y-axis in the first quadrant. And the other one, x equal to 0, is going to be your y-axis. And you have x equal to 1, which is a line parallel to your y-axis passing through the point 1 comma 0 and intercepting the line x equal to 1 at the point 1 comma 1. So our region R1 is this shaded region between these lines, and this is our region R1. So it's a triangular region which is lying in the first quadrant. Okay. With this visuality, let us compute mean, variance, and cross correlation, because the final solution requires all these three things in order for us to determine EMMS. So I recall my EMMS in this case is going to be sigma y squared minus, I will have mu xy squared divided by sigma x squared. So look, you need your variance of y, you also need your variance of x. For this we need to also know mean of x and mean of y, and then we also need to compute our cross correlation. So let us first compute all means. So in this first step, first let me compute my e of x. I know that my formula for e of x will be given by x ranges from 0 to 1, y ranges from 0 to x. I will have x fxy of x comma y into dy dx. So this becomes integral 0 to 1, integral 0 to x into 2 is a constant, we will pull it outside. Again I have to multiply with xy, so x squared y of our dx, dy and dx. Now upon integration, this would be integral 0 to 1, 2 is a constant. If I am to integrate with respect to y, x is also a constant. So y upon integration will give me y squared by 2. All this will run between 0 to x. So this will give me integral 0 to 1. I will have x squared by 2, or I am going to have x power 4. So in this position, I will have x power 4 into dx, which upon integration over here will give me this, on integration over here will now give me what is it that I am going to get, x power 5 by 5 between 0 to 1, which will land up to be 1 divided by 5. Okay, next I need to find my e of y. My e of y is going to be integral 0 to 1, integral 0 to x. I'm going to have y and then 2xy. So 2 into y squared x, I will have dy dx. So this is twice integral 0 to 1. Y, when I integrate, it will become y cube by 3. So this will be x cube by 3 into x of dx. So this will be 2. X power 4 will become x power 5 by 5 into our 3, all between 0 to 1. So this will give me 2 divided by 15. Okay, next I need to find my e of x squared. E of x squared is going to be integral 0 to 1, integral 0 to x squared fxy of x comma y into dy into dx. So this is going to become integral 0 to 1, 0 to x squared into 2xy dy dx. So this is twice 0 to 1, 0 to x cube y dy dx. This will give me twice integral 0 to 1. Y on integration is y squared by 2, and so you will have an x squared by 2. So x cube into x squared, x power 5 by 2 into dx. So this is going to lead me to x power 6 by 6, all between 0 to 1, giving me an answer of 1 by 6. Right. Next, our concern is about e of y squared. What is this e of y squared? 0 to 1, 0 to x, y squared fxy of x comma y into, you will have dy into dx. So this is integral 0 to 1, 0 to x, 2 x y cube dy dx. So this will become integral 0 to 1. Y cube will become y power 4 by 4. So 2 by 4 will give you a half. And here x power 4 into x will once again land up with x power 5 into dx. Is it so? Please check your answer thoroughly before you go on. See what happens in this location. I will have y power 4 by 4. So x power 4 by 4. 4 into 1 by 4 into 2. I will have a half, and here I am going to have an x power 4, which gives me x power 5. So this is going to be half into x power 6 by 6 between 0 to 1, giving me the answer to be 1 by 12. So my e of y squared, I am having this to be 1 by 12. Let us now find e of xy. What happens when we find e of xy? My e of xy is now given by the formula 0 to 1, 0 to x, xy, fxy of x comma y into dx dy. This is nothing but twice 0 to 1, 0 to x into 2x squared y squared. I will have dy dx. Evaluating this, I now need to find twice 0 to 1. I have another 2 which will make this 2 to become 4. Okay, so this becomes my 4. 0 to 1, y squared will give me y cube by 3. I pull out the 3, y cube upper limit x cube, so I will have x power 5 into dx. Look at this is 4 by 3, x power 6 by 6 between 0 to 1. So this will give me 4 divided by 3 into 6, or 4 by 18, which gives me the answer as 2 by 9. Okay, once I get this value, let me proceed to find my variance. So E sigma x squared is going to be nothing but my E of x squared minus E of x the whole square. Look into your previous slides. My E of x is 1 by 5, E of y is 2 by 15, so E of x is 1 by 5, so this will be 1 by 25. Let me write down my E of x 1 by 5, my E of x squared, I think it is 2 by 15, E of xy is 2 by 9, then E of x squared is 1 by 6, E of y is 2 by 15, and E of x squared is 1 by 6. So E of x squared, I suppose it is 1 by 6, and E of y is 2 by 15, E of x squared 1 by 6, E of y squared is 1 by 12. So my E of y squared is 1 by 12. With these things on hand, my E of x squared, let me just go one step above. E of y 2 by 15, E of xy 2 by 9. So E of x squared is 1 by 6. When I take, I will have 6 into 25. Both are relatively prime. So 6 into 25 will give me 6 5s are 30, 12 plus 3 15. I will have a 150. So I will have 25 minus 6. This value turning out to be 19 by 150. Similarly, I will find sigma y squared. My sigma y squared is now going to be E of y squared minus, I will have E of y the whole squared, which is going to be my E of y squared is 1 by 12 minus 4 divided by 15 squared. 15 squared is 225. So this will be again a huge number, which will be 225 minus 48 divided by 12 into 225. So 12 5s are 60, carry over 6, 24 plus 6 30, carry over 3, 12 2s are 24. So 2700, and the numerator is 225 minus 48. So this is going to be 225 minus 48 divided by 2700. This would give me 15 minus 8 7, 11 minus 4 7. So 177 by 2700, which is nothing but my sigma y squared. Once I get the sigma x squared and sigma y squared, my next task is to find mu xy. What happens to this mu xy? This is nothing but E of xy minus E of x into E of y. What is our E of xy? 2 by 9 in 2 by 9. So I will have 2 by 9 minus E of x is 1 by 5 and this is 2 by 15. So 1 by 5 into 2 divided by 15. In other words, it is 2 into 1 by 9 minus 1 divided by 75. So 3 is common over here. It is 2 by 3 into 1 by 3 minus 1 by 25. Resolve this. 25 minus 3 is 22 into 2 is 44 divided by, I will have 9 into 75. My 9 into 75 is 9 5s are 45, 5. Carry over, I will have a 4. 7 9s are 63 plus 4. I suppose it is 675. Please check if I am correct. I have taken my 2 outside. So I will have 75 minus 9. 75 minus 9 would be a 64. So in general, let me redo this once again. Sorry for the interruption. I will have 2 divided by 9 5s are 45. 5 carry over 4. 7 9s are 63 plus 4. 675. 75 minus 9, which is going to be 66. This, when divided by 3, will give me my 44 divided by 2 times and 6, again 2 times and 5. So I suppose this would be our final answer, 44 by 225. Now we have got all these values. Then we need to find A and B for minimum mean square error. Okay, so let me note down what are the values that we have obtained. I have to take the values of E of xy equal to, I have to take the value of E of x, I have to take value of E of y, I have to take value of E of x squared, I have to take the value of E of y squared, and then I have to take the value of mu xy. So my E of x is 1 by 5 and E of x squared is 1 by 6. My E of xy is 2 by 9. E of y 2 by 15. E of y squared 1 by 12. My mu xy, just now we calculated 44 by 225. Now keeping all this in mind, I need to calculate my A. A is E of xy minus E of x into my E of y divided by, I will have E of x squared minus my E of x the whole square. Look at it, the denominator is the variance term. So this would give me my E of xy would be 2 by 9 minus 2 by 75 divided by E of x squared minus this is nothing but my sigma x squared and sigma y squared value. My sigma x squared value is 19 by 150. So here I will have 19 divided by 150. So I will have a 2 common outside to be taken from the numerator. So when I take my 2 common outside from the numerator, I will have this value which I have computed over here, E of xy minus E of x into E of y, which is 44 by 225. So I can directly go for that. I will have 44 by 225 whole thing divided by 19 by 150, which is 44 into 150 divided by 19 into 225. Now 25 will go in this 6 times and in this 9 times. So it would be 44 into 6 divided by 19 into 9. Is it 19 into 9? Please check. 25 will go in this 9 times and 25 will go in this 6 times. So 25 into 9 will give you this value. This can be further simplified. So 6, 3 will go in this 2 times and 3 will go in this 3 times, giving you 88 divided by 19 into 3, which is going to be 57. From this, I can also calculate my B in a similar fashion. So what is the formula for calculating my B? My B is nothing but E of y minus A into E of x. What is our E of y? E of y is 2 by 15 and E of x is 1 by 5. So 2 by 15 minus A into 1 by 5. We just now calculated our A. Our A is 88 by 57. So 2 by 15 minus 88 by 57. Just check. Yeah, 88 by 57 into 1 divided by 5. We can take 1 by 5 common from both. Rather, we can even take 2 by 5 common from both. This would be 1 divided by 3 minus, what will I have here? I will have 44 divided by 57. 3 into 19 is 57. So I can take 2 by 15 as common. I will have 1 minus 44 divided by 19. So this would be 2 by 15 into 19 minus 44. 19 minus 44 will give me a minus 25 divided by 19. So this is going to be, I will move on to this side. 15, 5 will go in this 3 times and 5 will go in this 5 times. So I will get B equal to minus 10 divided by 57. So using this I can find the best estimate for y. Therefore, the best estimate of y the best estimate of y in terms of x is given by my y tilde equal to ax plus b. Come on, what is our a which we have found out? 88 by 57. So this is 88 divided by 57x, and what was my b? Minus 10 by 57. So this minus 10 divided by 57. Alright, now the first term here is 88 by 57. This is the variance of the error for the best estimate of y. So this particular term here is the variance of the error for best estimate of y in terms of mean. The final mean squared error is given by the second quantity over here. That is, I have to compute the second quantity. So the final minimum mean squared error of the linear estimate is given by sigma y squared minus my mu xy squared divided by sigma x squared, which I denote by EMMS. So here when we move on, what are these values? I need sigma y squared 1 by 12. So sigma y squared I will have 1 by 12 minus I need my mu xy 44 by 225. So minus 44 by 225. I have to divide by the variance. So when I have to divide by the variance, my variance value over here, sigma x squared value is 19 by 150, which we had got earlier. So 19 by 150, when I revert it, 150 by 19. So this is 1 divided by 12 minus, again you have minus 44. 25 will go in this 9 times and 25 will go in this 6 times by 19. So you have a 1 by 3 common again. If you are interested, it is 1 by 3 into 1 by 4 minus 44. Um, Here you will have a 3, here you will have a 2, so minus 88. This 3 has come out divided by 19. Please evaluate this value. This value will give you your EMS. Right? Now I have to pose a question for you. Can EMS be negative? Please respond. This is what I have left for you. However, you can look at the illustration. The values are taken for computation purpose and we have obtained the desired results of computing the best estimate of y in terms of x and also the minimum mean squared error. And I want you to resolve for yourself, can EMMS be negative?